Welcome back, kids. We're going to take a look at lesson 4.2 today. Look at the screen. Our skill practice today is long division of decimals and solving for variables. Then we're going to review what we went over yesterday to see if we can't solidify remembering what discrete and continuous domains are all about. Go ahead and write down this problem on your worksheet. We're going to divide the whole number 6 by 4/10. We can do this by putting a division box, and we'll go ahead and fill this out. The divisor, the number doing the dividing, is going to be on the outside, which is 4/10, and the dividend, the number being divided, will be on the inside. Now, you must remember that you cannot divide by a decimal. You need to make that a whole number. The only way that you can do that is by moving the decimal place. So we'll take this 4/10 and we'll move the decimal once to the right, okay? And we must do the same on the inside, and we have 6 here, and the decimal is going to be on the right side already, so we'll move that over and we'll put a 0. Now we can do our long division. And we'll take this and say, how many times does 4 go into 6? 6, it goes in once, and 1 times 4 is 4. We have 2 left over. Drop our 0 down. How many times does 4 go into 20? It goes in 5 times, and that zeroes us out, okay? Make sure we have these there. So our answer for this division problem, we'll put it right down here in this box, is when 6 is divided by 4/10, you get 15. We're going to go ahead and do this problem now, and 25 hundredths, which is up here, we're going to divide that by 1.25, 1 and 25 hundredths down here. It's already been set up. So let's go ahead and do this. We're going to go and make sure that we move our decimal place twice to the right on this, which makes it 125. And we will go ahead and move this decimal place twice to the right, which turns that into 25. Once we put our decimal place here, since we know that we're going to be dividing by a larger number, we'll go ahead and put it up in the top. And we ask ourselves, how many times does 125 go into 25? It goes in 0 times. Once we've done that, we go ahead and add another 0 here and ask the question again, how many times does 125 go into 250? It goes in twice. Multiply that out and we get 250. This is very simple for us to do today, and we get 0 here. So when we've done 25.25 divided by 1.25, we get 0.2. It's a very small number, 2/10. Our next problem we're going to work is an algebraic problem. We're going to solve for x. First thing we need to do is get rid of the constant on the left side of the equation, and we must do what's called the inverse. So that's a -7. The inverse of -7 is going to be +7. We're going to add 7 to both sides of the equation, and when we do that, this cancels out. All we're left with is 2x on this side equals 14 plus 7, which is 21. Now, we need to go ahead and take care of getting the x by itself. The x is being multiplied by the 2, so the opposite of multiplication is division, so we're going to divide both sides by 2. And once we do this, we have x by itself over here equals 21 over 2. Now, we can leave it as an improper fraction or change it to a mixed number, which would actually be 10 and 1/2. Let's try this again with 3x plus 4 equals 24. Taking care of the constant on the left-hand side, we'll go ahead and do the inverse of plus 4, which is -4, and we'll subtract 4 from both sides of the equation. Once that is done, we will have 3x equals 20. And now we'll need to go and get the variable by itself, and we must do the inverse of multiplication since the 3 is multiplying the x, and we will go ahead and divide both sides by 3. And once again, we cancel this out and we have x by itself equals 20 over 3. Let's look at long division's style of dealing with this so you can see how this can be worked out. The 20 is being divided by the 3. So we will put our division box up here, and we'll put our 20 on the inside, 3 on the outside real quick. 3 does not go into 2, but 3 does go into 20 6 times. 6 times 3 is 18, and we will go ahead and subtract. We have 2 left again. 3 does not go into 2, so we must drop down to 0. 3 goes into 20. We must put our decimal place there. It goes in 6 times, and we get 18 again, and we will go ahead and have 2 left over. Now this is interesting. What we're going to get is a repeating decimal. When you have that, you don't have to write them all out because they never end. Just put a repeatant over that, and there you are. And that will be your answer. It would be 6 point repeating 6. Here's your secret word for today. It is a churro. Let's review from yesterday. A domain is a set of numbers that you can put into a function. If you look at this graphic, this function is like a machine. It deals with the domain numbers that you put in and gives you an answer, which is your range. The domain numbers that you put into a function can be considered either discrete or continuous. We'll take a look at a picture next, and it will show you what that would look like on a number line. Pay attention to the domain is going to be your x value, and your range, which is the answer of how the number changes through the function, is going to be your y answer. This is important when graphing, and we're going to see how that will take place here shortly. Here are your vocabulary words that you need to write down for today: discrete domain and continuous domain. If you notice, there's a visual that tells you a little bit more about the difference between continuous and discrete. Discrete meaning things are separate. You can see all of these are separate. And continuous meaning it just continues all the way through. It is interesting to note that continuous means there are infinite possibilities between that interval of numbers there. Between 1 and 5, you have decimals that go on and on. You could have 1.2, 1.3, 1.4, 1.5, all the way to 2, then 2.1, 2.2, and so on. And this is a continuous set. We're going to take a look at some examples of what a continuous number would be for a domain and what a discrete number would be for a domain next. Here's an example of a discrete domain. Buying tickets for a museum. We'll show you what the graph looks like in just a moment. But you are not able to buy a partial ticket. So if you see here, all of these are the individual tickets bought. And using this function, which is like your equation, you plug the x in, you do the math, and you get your output. That is your range. These are all discrete. Take a look at the graph of this. When each of the discrete numbers had been put into the function, you can see how they have been graphed. Take a look here at these values. The x and y, you see that this is x and this is y. This is x, this is y, and you have the discrete placement of these values. You can't buy a partial ticket, you can only buy a whole ticket, so that's why this is a discrete representation of a domain. Here's another example of a domain, but it is continuous. Look at, you have your bars eaten, and there's calories per bar. So if you take a look at both of these values, you can see that if you eat a partial bar, you're going to get a partial number of calories. Each bar, if you ate the whole thing, would be worth so much. But if you eat part of it, you only get a fraction of the amount. So that's why this is considered a continuous representation. Okay, Mr. Churro, we're done. You better run. Hey kids, see you tomorrow in class.